So integration rules. So this might be a review, the 10 items that I'm going to write here, and then we're going to start chapter 7. So let's just write integration rules. Number 1, integral of x to power n dx is equal to, we did that multiple times this week, x to power n plus 1 over n plus 1 plus c. You're basically adding 1 to the power and divide it by that power. 2, integral of 1 over x. What is that equal to? Dx. Integral of 1 over x dx. Excellent. ln of absolute value of x means regardless of if x is positive or negative, I need to say absolute value of x plus c. So I want you to have this list nice and complete on your notes and memorize it again. Number 3, let me alternate colors so it's going to be nicer. Every 2 I alter. E to power x dx. Integral of e to x dx is the same thing as e to x plus c. Identity. Derivative of e to x is e to x. Integral of e to x is e to x. Another one. Tricky. Number 4. If you have a base b, this time is not e, anything to power x, any exponential functions. What would be the antiderivative of that? What is the integral of that? Does anyone know? One way to memorize it, you can say, oh, e to x is the same thing as e to x over ln e, and ln e is 1. So when it's b to x is b to x, b to power x, over ln b plus c. Again, these are the first 10 of the table that I'm writing. So that means if you had integral example, if you had integral of 2 to power x dx is equal to 2 to x over ln 2, and ln 2 is a constant, right? Plus c. Make sense? Questions? Okay, let's keep going. Number 5. Integral of sine x dx is equal to, I think we did that multiple times this week. What is integral of sine? Cosine or negative cosine? All of you respond. I want to see how you're remembering that. Awesome. Negative cosine x plus. Number 6. What is integral of cosine x dx? Sine x or negative sine x? Exactly. Sine x plus c. So now let's go to number 7 and 8. So I would say 1 through 6, you use it very often. Then next few are also useful, like number 7. Very useful. Secant square x dx. What is integral of secant square x dx? What was that thing, that trig function that when you take the derivative, you're going to get secant square?
And
Excellent. So that's 10. So integral of secant squared dx is 10x plus c. Derivative of 10 is secant squared. Antiderivative of secant squared is 10. Same thing with the cosecant. Cosecant square of x dx. Negative cotan x plus c. Number 9. You use number 9 and 10 as well, but less often compared to 1 through 8 or 1 through 6. So integral of secant x 10x dx is equal to secant x plus c, and integral of cosecant x cotan x dx is negative cosecant x plus c. Here is the full list. Okay. Any questions so far? Can I move on? Do you need more time? Okay. Chapter 7. Rules of integration will expand. 7.1. We use all these basics, but we apply some strategies. So integration by parts. Integral. So here is the formula of integration by part. If you have, let's start with this. If you have f of x times g of x, f of x times g of x. And I ask you to find the derivative of this one. I want you to write down what you think is the derivative of f of x, g of x. I'm going to write that with d dx. So same thing as finding the derivative. When you have two functions multiplied by each other, how do you find the derivative of that?
left d right and right d left.
Say it again.
Left d right and right d left.
Exactly. So you would say derivative of the first one times the second plus derivative of the second times the first. So I'm going to write that. So you keep one. So you keep one, for example, f of x, and you say the order is not important. So you keep one times derivative of the other one plus you keep the second one this time times derivative of the first one. Do y'all remember that?
Yes.
Okay, now if I take the integral of all sides, and again, this is one of the ones that we show the steps and proofs, and then we only use the results here. Okay, so if I take the integral of all sides. And I'm going to add dx here for the integration. Then what would I have as a result of integral of d dx? Do you agree that that disappears each other because integral and derivative are opposite of each other, so undo each other? So then you would have f of x times g of x here equal to integral of f of x times g prime of x dx plus integral of f prime of x times gx dx. I pretty much rewrote everything else. So just integral and derivative cancels each other. Okay, now I'm going to subtract both sides by f prime of x gx dx. Integral of f prime of x gx dx. So that cancels. So now I'm going to rewrite it. Integral of f of x g prime of x dx is equal to f of x times g of x without integral. You remember that integral canceled. Minus integral of f prime of x gx dx. Okay. Does that make sense so far? So do you see what I did? I started the proof with multiplication of f and g. I wrote the rules of multiplication rules. And then I took an integral of everything. Derivative and integral on the left side canceled. And I brought one of the integrals to this side. So now I'm going to let, and this is the result we're going to be using. I'm going to let u to be, I'm going to let u to be f of x. I'm going to let g and v to be g of x. And then, so I'm going to replace the things that I can replace here. What is going to be as a result if I have du? It's going to be derivative of f prime of x dx, and dv is going to be g prime of x dx. So now let's substitute all of them. So from here, I'm going to substitute the last step. Integral of u, instead of g prime dx, I'm going to put dv. U dv is equal to u times v for f and g minus, instead of f prime dx, I'm going to put du, and instead of g, I'm going to put v. So this is the result that you are using for integration by parts, and I'm going to give you a lot of examples on them, multiple examples. U dv, integral of u dv is equal to integral of uv minus v du. If that makes sense. So the proof is not, I'm not going to ask you to prove it, but I want you to know where the formula came from. And you will be using the result. So here is an example. So write down the formula. Example 1. integral of x sine x dx. To this point so far, anytime you wanted to find an integral, you wanted to evaluate it, you wanted to calculate it, you had to use substitution. That was pretty much the only method you knew. From now on, I'm going to give you different strategy for different types of questions, and you need to practice and know where to use what. I want you, when you are doing homework, please do not use the online platforms where they have integral calculation for you, because that's not going to help with your critical thinking of what method to use when. So here we go. X sine x dx. Dx and integral are just for integration piece for now. Just x and sine x. Think about it. They are two different functions. Use substitution wouldn't help. And these are two different things, like f and g, two different functions. So then I would tell myself, maybe integration by part is the smartest. When you are doing integration by parts, you need to come up with what is u and what is dv. So these are the two things that you need to come up. Do you see that the original formula has u dv? So you need to say, oh, do I let x to be u and then dv to be sine x dx? So what do I let to be which one? And sometimes you make mistakes in process of picking them. If you pick them incorrectly, you will not get to any answer. So then you go back and switch. Let's look at this example here. I'm going to let u to be x, and I'm going to let dv to be sine x dx. So I need to assign everything to be u and dv. So as a result here, du is equal to what? So I'm taking, so every time, let me just tell you this one too. Every time when you come up with u and then dv, then as a result of that, you need to come up with what is du, because on my formula here, I will need du, I need to have v, I need to have u, and I need to have v. So far, I assigned u, I assigned dv, but I still need to find v, I still need to find du. So basically for the formula, you say, what is u, what is dv, and then you come up with the other two. If u is x, what is du?
1.
1, but then also derivative of x, so dx. So just 1, but then every time derivative of something, because there might be a function or partial function inside, so you would have the dx. So derivative of u is du, derivative of x, yes, it's 1, but also dx. What is derivative of, so now dv, please pay attention to this one. dv is sine dx. Do you see every d has also on the other side a d? Because they are partial derivatives. So if dv is sine x, or sine x dx, what is v itself? If d, what is it? Negative.
Cos.
Exactly, negative cosine x. So because derivative of cosine is negative sine, but this is positive sine, so negative cosine gives a positive sign. As soon as you set this up, then you would follow the formula. You say, oh, I have u dv. So on the other side, the formula says, now multiply u and v. uv negative x cosine x minus integral. So you are creating another integral, but then hopefully that integral is easier than the one that you began with. So uv minus v du, integral of v du. So what is v? V is negative cosine x. V du is these two together multiplied. Negative cosine x dx. So now let's continue. So we are finding the derivative of the original one. We got to this step. So far, one piece has no antiderivative. Minus makes it plus. These two together makes it plus. What is antiderivative of cosine? Or what is integral of cosine? Positive sign, and then plus c. So the integral of what we had at the beginning is this. So I want you to take a minute. I'm going to give you a minute. Find the derivative of the answer and see if you get the original back. So I want to give you 1 minute. Check your work. Remember, when you are finding antiderivative or derivative of negative x cosine is derivative of the first one times the second plus derivative of the second times the first, and then adding derivative of sine. So here is a minute. Check your work and tell me if you get the original. Okay, let's do it together. So derivative of the first one. Did you get to the original? Derivative of the first one, -1 times the second, plus derivative of the second, that's negative sine, times the first, plus derivative of sine, that is cosine. So as you can see, cosine, positive and negative cancels. The final result is multiplication of negative x and negative sine, which is x sine x. And do you see that's the same thing as what we began with? So that's how you can check your answer every time. Not that it's needed, but if you have time. Okay, any questions? Let's do another. Example 2. Number 2. Integral of ln, let me give you one easier and then this one. Integral of t e to power -3t dt. Okay. So how do you know that this is integration by parts? Substitution wouldn't work. So then there would be 4 or 5 different kinds of a strategy that I'm going to give you in this chapter. And then, so you know, t is a power function, e to power -3t is exponential function. So there are 2 different kinds of function multiplied with each other. So then you would say, oh, maybe integration by part is the solution. Yes, every time when you're writing down dv and du, it will have the partial derivative of dx in there. Okay, I also answered a question in the chat. Okay, so now in the process of when you're going like even in I think one of the YouTube videos that I put under module, they give you rules. Oh, if you had power function with exponential, let power function to be the u or this and that. I want you to come up with some critical thinking strategies of how do I pick it? So first off, write u and dv. So tell yourself, what is my goal? I want to reduce my integral to something easier. If I let t to be u, then du would be just dt because derivative of t is 1. So I'm reducing my next integral. So exactly like the one you had here. Did you see that with x, you reduced it to dx? That's why here you didn't have x anymore. So one of the strategies to pick a right u or dv is by picking a right one, you will be reducing the power of integral to something simpler. So, and again, don't be afraid if you pick it wrong, if you pick one to be like switching them, because it's not going to get you anywhere. Your new integral will be harder. So then that would be an alert. Oh, I need to go back and change it, if that makes sense. So I let u to be t, and I let dv to be e to -3t dt. To me, this is more than 50% of the problem if you pick it correctly. Because after that, it's just simple finding derivative and finding antiderivative or integral. So I want you to do that. So come up with then what is du and what is v. In order to go from dv to v, you are taking integral. In order from u to du, it's derivative. Integral of a derivative of t is just dt. And then from dv to v, it's integral of e to negative 3t dt, because in order to find v, I need to say, oh, what was that thing that its derivative is this? So you need to take integral in your head. Either you know it well, or you just need to do it separately. I'm going to show you how the works go. Integral of e to x, or e to u du in general, is e to u. But then this one is negative 3t. So I'm going to do some, let's say, w substitution. Negative 3t to be equal to w. Then dw is equal to, that's like a u sub or w. So I'm going to name it w sub this time, because it's not going to be confused with the u and v up there. So dw is negative 3 dt. So what you're going to do here, this is going to be, I'm going to substitute the integral e to power. Instead of negative 3t, I'm going to put w. Instead of dt, I'm going to divide both sides by negative 3. So it's dw over negative 3, or times negative 1/3. And then from here, I would have negative 1/3 integral of e to w. dw is just e to w. I'm going to substitute w back by negative 3t. As you do more integrals, then it's easy for you to see, maybe without doing this process, that if dv is e to negative 3t, v is e to negative 3t over negative 3. Now, if you take derivative of this one, you get the original. Maybe from the beginning, you didn't need to do this one. In your head, you can say, what should this be that if I take its derivative, I get e to power negative 3t? So then I have to divide by negative 3 as well, because the derivative will have a negative 3 in front. So then they cancel and I have the original. Okay. So here we go. Now, again, going back to the formula you have, u dv is equal to uv minus v du. u dv, which was here, it's uv t times e to power negative 3t over negative 3 minus integral of v du, e to power negative 3t over negative 3 times dt. This might be your first time working with integration by part, most probably. So it requires a lot of practice. I don't see anything else. I mean, you may watch the YouTube videos I put, or search up more YouTube videos for memorizing. Oh, what do I get as u? What do I get for dv? But the best way is to make your brain think rather than memorizing of what to do. So now your integral is now simpler. So instead of the original, now you have this. Okay. So I'm going to write the first piece out, negative t e to negative 3t over 3. So I just rewrote this one. So this is just the rewrite. And then minus, and this one makes it plus. So plus integral of e to negative 3t dt. Just a few minutes before, when I was going from dv to v, we did the calculation that e to negative 3t dt, integral of that is e to negative 3t over negative 3. And then I'm going to write the first piece out. I'm not going to make you to check your work this time, but feel free to do it. This is the result of the integral. Oh, I had a 1/3 here as well. Sorry. So then this is -9. Okay, that's it. Any questions? Yeah, you can think about it as a reverse of, you mean chain rule, or because we started with multiplication rule, so do you see it's not much of a chain, is multiplication of two functions. Maybe as we had in the beginning, think about it as somehow reordering the multiplication. It always works if that's the method of, if you have two different functions and they are multiplied with each other. I mean, when we say always in math, is very relative. I would always work within the type of questions that you receive here. Okay, let me give you another one. So did I answer everyone's question so far when they put in the chat? So if you feel that your question was not answered, feel free to write it again. Okay, integral. Let me go to the next page. Integral of ln of, this is a bit tricky. And then if you tell me after years of teaching, and then many years of learning integrals, if you tell me, how do you know that I need to use integration by parts for this question? Because you see only one function there, and that's ln. If you tell me, how do I know that I have to use integration by parts here? I would say just by practice, knowing that if I let u to be ln, again, my function will be reduced. So in this case, you have one function, and that's just ln. The other one is just dx. So again, by practicing. So practice this, practice the homework that I put online. Hopefully that will prepare you well for the test. U dv. Okay, u, most of the time, in many cases, if you have ln compared with anything else, most of the time, you let ln to be u. And you're going to see why. Because if I let ln to be u, what happens when I find du? Then in process of finding du, my function will be changed from an ln function to something that has an x in denominator. So it's much easier to work with. So, okay, so let's complete this one. Let this to be u, then this is dv. So dv is just dx in this case. Okay. So now I want you to think. Ln of cube root of x is the same thing as ln of x to power 1/3. Are you all with me? What is derivative of that? You take 1/3 to the front. So that's 1/3. And then ln of x, derivative of ln of x is 1/x, right? 1/3 times 1/x is 1/3x. And then what is, now it's okay. So do you see, as dv to v, you're increasing the power of the function, but you're going to see that it's going to be fine. So 1 dx, or just dx, is dv. Then what would have been the v?
X.
Excellent. X. So now let's just write it. uv x ln cube root of x, multiplication of the two, x ln cube root of x minus integral of v du. Oh, I forgot dx here. So v du, any du, any dx, any dv has to have dx in there. So then v du x times 1/3 x dx. Okay. So, and here is the beauty, x and x cancels. So I rewrite the first one, x ln cube root of x minus integral of just 1 dx. What is integral of 1 dx? Excellent. Yes, x. And then I had the 1/3 as well. Oh, today I keep forgetting the denominator. Yep. So, and then 1/3 that I had from here to here to here. Done. Okay, negative x/3. That's the final answer. Again, you feel free to check. You don't have to if you trust your work. Let's do one more. Any questions? Let's do one with trigonometry. Trigonometric function. So example 4. Integral of x to power 5 cosine x cube dx. Now you are comparing power function with cosine. So again, I brought up this example to show you that sometimes it's not as easy as, oh, I get x to 5 as my u, and then du would be the cosine x to 3. And again, how do I know? By practice. Just these 4 or 5 examples that you have today from the lesson, and then 10 examples that you see on the homework, that should prepare you for the test. If you see similar questions, then you need the strategies. So again, I bring questions with harder level of sort of difficulties, so you would see them before you go to the homework or the test. So u dv. So in this case, I would ask myself, if I let just cosine of x cubed. So you remember I said whenever you have power functions involved compared with sine, cosine, e, you would let power function to be u. When it's ln is usually u because ln would be nicer with the u. But anyways, you would say, okay, if I let x to 5 to be u, and then cosine of x cube dx to be dv. So this course is a little bit different than Calc 1. So in Calc 1, everything was like a recipe. Take this, multiply by that, divide by this, and you're done. This course, one reason that I love teaching it always, it's that you need to think. It's not as straightforward as, follow this recipe and you'll be done. So look right here. If I was letting it to be this way, when I want to find go from v dv to v, when I want to find the integral of cosine of x cube dx, it would be very difficult because I don't have, if I let x cubed to be like w, and then dw would be 3x squared, I do not have 3x squared here. So then that doesn't really, I cannot find, then it would be as difficult to find integral of cosine x cubed to find v than the original. So then I would go back and think to myself, okay, what if I let u to be x cubed, and then I let two of the x's or x squared to be multiplied with cosine x cubed. So do you see that? Do you see why I did that? So I would say, okay, it doesn't matter. Then I would be providing the dw, or for my u substitution later, I'm just providing that du or dw. So now if I let w to be x cubed, dw is 3x squared dx. And there we go. I have x squared dx here. I just need to divide both sides by the constant 3. So it would be 1/3. Instead of x squared dx, I put 1/3 dw, and then cosine w. So then what is antiderivative or integral of cosine is sine, so it's sine w, and then I have the 1/3, and I replace w by x cubed. So up here now for v, I have sine x cubed over 3. Isn't that amazing? And then for du, I have 3x squared dx. So I just take the derivative of x cubed. Okay, can I erase the work that I found v? I found v by w substitution or u substitution. Sometimes going from dv to v, you can do it in your head. Sometimes you need w in substitution. So now you would say uv without integral x cubed times sine x cubed over 3 minus integral of v du sine x cubed over 3 times 3x squared dx. 3 and 3 cancels. Now I need to deal with this integral. Do you think it's easy to find this integral now? X squared sine x cubed dx. Is that easy? Yes, no? How do I do it? Let's see how many of you are paying attention. Tell me, how do I do that?
U sub.
Exactly. Another U sub, very, very similar to the to the one that we did with DVV. With the same process, you would get sine of probably W. So let's just do it. So you would let x cubed to be W, so W to be x cubed, dW to be 3x squared dx. And then you would go with integral of 1/3 sine W. Instead of x squared dx, I'm going to put dW. And then antiderivative of sine is negative cosine. So negative 1/3 cosine W, which cosine W is x cubed. Okay. So now I'm going to rewrite my final answer with this red, x cubed times sine x cubed over 3. And then minus and minus makes it plus. This minus and this minus makes it plus 1/3, or just 3 in the denominator, cosine x cubed plus c. Final answer. Okay. Any questions?